In this video, or today, we're going to look at one new concept, and then we're going to review what we've done this week. So, new concept we're going to learn has to do with percentages, and it's called marginal distribution. And this comes up when we have tables like we were looking at before. Actually, before we get into this, let's just go ahead and review percentages. So here we have a table that represents seniors in college and their plans, or seniors in high school and their plans after high school. Do they want to go to four-year college, two-year college, military, go straight to employment, or do they have other plans? And were they white or a minority? So let's just go ahead and ask some questions involving percentages. Let's say, what percent were white? What percent were white seniors with military plans? What percent of white seniors had military plans? And what percent of those with military plans were white? So what percent were white? So it doesn't tell us any specific group we're looking at. Like if we look at the last two questions, it says what percentage of blank, what percentage of blank. But here it just says what percent. So if it doesn't give us a specific group we're looking at, it just means we're looking at everybody. And in these tables, you have the grand total of people on the bottom, bottom right. This is the total of everything. So the group that we're talking about, the number in the group we're talking about goes on the bottom of our fraction. So we have 325 on the bottom here. And then it says what percent were white. So we put the number of white students, seniors on top, and that's 268. So then I'm going to pull up my calculator here. And remember, it's always the top one divided by the bottom one. So I'm going to type in 268 divided by 325. Remember, if you're using one of the graphing calculators in our classroom, you have to hit Control Enter. Otherwise, it stays as a fraction for some reason. And it looks like we get a lot of digits, but again, we'll just stick with the first four. 8, 2, 4, 6. And then to turn it to a decimal, or to turn it to a percentage, we move it 2 times to the right. And so we're going to have 82.46%. So way over half of them were white students. Next one, what percent were white seniors with military plans? So again, this one doesn't tell us any specific group we're looking at. It just says what percent. It doesn't say what percentage of minority students, what percentage of students going for employment. And so it just says what percent. That again means we're talking about the grand total. So it's going to be over 325. And says white seniors with military plans. That'd be these ones right here. It's white, military. 4 out of 325. We divide those. 4 divided by 325. Enter. And we get approximately 0.0123. Move the decimal 2 times to the right, and we're going to get 1.23%. So overall, there weren't that many white seniors with military plans, or they didn't make up a large percentage of the group. Now, next one, what percentage of white seniors had military plans? Now it's telling us we're looking at a specific group. Who are we interested in learning about? White seniors. It says what percentage of white seniors? So we're only looking at the white seniors. That means every number we use should come from this column. We're only talking about the white the seniors. And so the total number of people in the group we're talking about goes on bottom. That's 268 white seniors. And it says what percent of them had military plans? That's going to be 4. So 4 divided by 268 is approximately 0.0149. Move the decimal 2 times to the right, and we're going to get 1.49%. Remember, we're doing the squiggly equal sign because we're not writing down the exact number with all the digits. We're just writing down the first 4. So it's no longer the exact answer. It's only approximately equal to. And then last one we have here, what percentage of those with military plans were white? So now who's the group we're interested in? Those with military plans. So we're only looking at those with military plans. So all of our numbers should come from here. What percentage of those with military plans? So the total number of people in the group we're interested goes on bottom. There's 5 people in total with military plans. How many of them were white? 4. So 4 out of 5. If we divide that, we'll get 0.8. Which is 80%. Yeah, so if you put that into a calculator, 4 divided by 5, you get 0.8. Move the decimal 2 times to the right. There's an empty spot, so you put a 0. So we have 80%. So let's just go ahead and try practice. Try maybe 2 different scenarios. Let's say what percent were minority students with other plans, and what percent of those planning for 4-year college were minority students? So first one, what percent were minority students with other plans? Second one, what percentage of those planning for 4-year college were minority students? So let's go ahead and pause the video and give these a try. So first one, what percent were minority students with other plans? This one doesn't give us any specific group we're looking at. It just says what percent. It doesn't say what percentage of this particular group. It says what percent. That means we're talking about everybody in total. And there's 325 people. What percentage were minority with other plans? Let's see, minority, other, that's 3. So 3 divided by 325 is approximately 0.0092. Move the decimal 2 times to the right, 1, 2, and we get 0.92%. And whenever you have that, you just have point something, just put a 0 in front so that it's easier for people to see that there's a decimal there. If you just put the 0.92, it can be a little hard to see the decimal. So put the 0 in front, it doesn't change anything. And so that's our answer, 0.92%, so less than 1%. The question would be, what percentage of those planning for four-year college were minority students? So this one's telling us a specific group to look at. What percentage of those planning four-year college? So that means we're only looking at those planning for four-year college. All of our numbers should come from this row. So how many people in total are in this group? Those planning for four-year college, it's 242, that goes on bottom. And we're looking for four-year college minority students. That's 44. 44 divided by 242, I'm gonna plug that in. And that gives approximately 0.1818. Move the decimal 2 times, 1, 2, and we get 18.18%. So that's a review of percentages. Now let's look at this thing we talked about, this new thing for today. It's called marginal distribution. The word margin basically just means edge. Like if you have a piece of paper, the area off to the side is called the margin because it's on the edge. So marginal distribution, and distribution just means how things are spread out. Is a lot over to one side and a little over to the other side, or vice versa. So, oh wait, I spelled marginal wrong. There should be a G. Marginal. So what marginal distribution is, well, let's just come up with a type of question you'd be asked. Like, what is the marginal distribution of, we'll say, plans. So it's called marginal distribution because we're looking over here in the margin. Again, margin means edge. We're over here at the edge of the table. And there's two edges. There's the edge down here and the edge over to this side. So both of these margins. And how do you know which one you're working with? Well, it tells you. What is the marginal distribution of plans? Well, the marginal distribution of plans, so these are the different plans right here. And the margins for plans are over here. These are the totals that correspond to plans. So we're looking at this margin. So marginal distribution is basically just saying what percentage falls into each of these categories. What percentage four-year college, what percent two-year college, military, employment, other. So to find those percentages, we just need to divide. So this one, unfortunately, there are going to be a lot of things to divide. So let's see. So four-year college, and we'll just sort of abbreviate. We'll say four-year college, two-year college, military, employment, other. So what percentage are looking to go to four-year college? Would that be 242 out of the total 325? 242 over 325. Two-year college, that'd be 42 over 325. Military, that'd be 5 over 325. Employment, that'd be 17 over 325. And then other, that'd be 19 over 325. So then you would divide each of these, you'd get percentages, And those percentages would add up to 100%. And it'd tell you how things are distributed. So as you can notice here, majority of people, looks like a good amount, over 50%, are planning to go to four-year college. And a very small amount are planning to go to the military. So you can see how things are distributed among these different possibilities. So I'm just going to go ahead and divide these real quick. 242 divided by 325. And I'm just going to go ahead and kind of round them in my head because we've gotten a good amount of practice with this. So 74.46% for this one. And then 42 divided by 325. We get 0.1292, so that's about 12.92%. And we have 5 divided by 325. We get 0.0153. So that's 1.53%. Then 17 divided by 325. We get about 5.23%. And then last one, 19 divided by 325 is about 5.84%. So again, all of these should add to 100%. Because we're dealing with decimals that have a lot of digits, there may be issues with rounding so that they don't add up to exactly 100%. At this point, we won't worry too much about tweaking things so they're perfect. We just want to have kind of a rough idea. So your answer to this question, you would say 74.46% plan to go to four-year college, 12.92% plan to go to two-year college, 1.53 plan to go to the military, 5.23 plan to go to employment, and 5.84 have other plans. And that'd be the marginal distribution. So let's go ahead and try a practice. We may not be ready for practice on this concept yet, but let's try it out. And so this table, if you remember, it's talking about whether the respondent to the survey was male or female, and whether they're liberal, moderate, or conservative in their politics. So the question we're going to ask here is, what is the marginal distribution of, let's say, politics? Or no, let's say sex. Actually, I think we did sex on the classwork, so let's do politics. Actually, so what is the marginal distribution of politics? Let's go ahead and pause the video and give this a try. All right, let's have a look. So marginal distribution of politics. So we're looking at the margin. So either this one or this one. And which one is it going to be, margin A or margin B? We're talking about politics. If we're talking about politics, we're talking about margin A, because the total for liberal, moderate, conservative are down here. Margin B would be if we're talking about sex. So we're talking about politics. So margin A down here. And we include the grand total. And so we're just saying how things are spread out. So we're talking about politics. So we're going to talk about liberal, moderate, and conservative. So for liberal, moderate, and conservative, let's see what we get. So liberal, there are 85 out of 192 people in total. For moderate, 80 out of the total of 192. And then conservative is 27 out of 192. So now we're going to go ahead and divide each of these. And this one, since we don't have so many, let's actually see if we can get it to add up to 100%. 85 divided by 192. That's 0.4427 approximately. Move the decimal 2 times. That give us 44.27%. Then moderate, 80 divided by 192. That gives us about 0.4166. And this is one that a rounding issue could come up on. We haven't talked about rounding. We're not going to focus on it just yet. So let's see what happens. So this one's going to be 41.66%. And then 27 over 192. We get approximately 0.1406. Move it 2 times, 14.06%. Actually, it looks like these might all add up to 100. I'm going to put them in a calculator to check. 44.27 plus 41.66 plus 14.06. Okay, so see, those do add up to 99.99%. So that was probably a rounding issue on this one. This should probably be 41.67%. But actually now, before we go into it, let's just go ahead and leave our answer. Just keep that in the back of your mind that you may need to tweak things in the future. So for our answer, again, we'd write this out as a sentence. So we'd say the marginal distribution, 44.27% of people were liberal, 41.66% were moderate, and 14.06% were conservative. And one thing you could do to address those rounding errors, you could just, again, put that word approximately. So approximately 44.27% were liberals and so on. All right, so let's move on to review of other concepts we looked at. All right, so first we're going to look at sample and population. So we're going to read over this and try to figure out which one's the sample, or what is the sample and what is the population. Oops. Winston was a marine biologist who wanted to learn about the present health conditions of dolphins in the Pacific Ocean. He and his team began to monitor 24 dolphins off the coast of California. So remember that population is everything, basically the total group we want to know about. And then sample is the group we actually study, because we may not be able to study every single thing in the group we want to know about. Like if we want to know about every single person in the world, we probably can't study every single person. So we might study 100 people. That would be our sample. So here, Winston, what does he want to learn about? What's everything he wants to learn about? Let's see. He wanted to learn about present health conditions of dolphins in the Pacific Ocean. So what do you think we're going to put for population? Dolphins. But we can be more specific, and we would want to be more specific. He doesn't say he's interested in learning about all dolphins, just dolphins in the Pacific Ocean. Dolphins in the Pacific Ocean. And then does he study all dolphins in the Pacific Ocean? No, it says he and his team monitored 24 dolphins off the coast of California. So 24 dolphins, and also you want to include as much information as is provided. 24 dolphins off the coast of California. Because those dolphins may be different than if they studied 24 dolphins on the other side of the Pacific Ocean. Could be different. You want to include that information. So let's go ahead and try a practice with population and sample. So let's pause the video and give this one a try. So Darla was a botanist who wanted to find the most effective store brand fertilizer to use on houseplants. She went out and purchased 8 different brands of fertilizer from her local garden center. So what is our population? What is the total group that Darla wants to know about? It says most effective store brand fertilizer to use on houseplants. So careful, you wouldn't want to say all fertilizer. She does specify store brand fertilizer. Maybe there's some fertilizers that aren't for sale in stores, like maybe just like cow manure or something. So population, all store brand fertilizer. And then the sample, what does she actually study? 8 brands of fertilizer. And also we want to add this from her local garden center, because maybe her local garden center carries different brands than most other places. It could be. So we want to include that information. Let's move on to another one. Let's see, how are we on time? Let's move on to this one here. So we'll do this one, we'll do one more practice, and then we'll move on to classwork. So this one, we're gonna talk about the 6 W's. Athena was planning to open a gym and wanted to find the best treadmill brand and model to buy. In fall of 2017, she went out to an exercise equipment warehouse in Amarillo, Texas, and began, or is that Amarillo? I'm not sure. And began testing different models. They had 30 in total, all of which she tested. For each treadmill, she noted the top speed, brand, model number, inclinability, comfort rating, cost, and weight. So let's go through our 6 W's and figure out as many as we can. Again, it might not provide information on every single one. Well, let's start with who. Remember, who doesn't necessarily have to be people. Who is the person or things that we're collecting information on? So in other words, it's the sample. So let's see. She went out, okay. It says she began testing different models. They had 30 in total, all of which she tested. So the who is the 30 different treadmill models at the warehouse in Amarillo, Texas. Those are the things, the group she's collecting information on. Then, or let's come back to what, actually let's try to squeeze it over here just because we need a lot of room for this one. Because what, if you remember, is just the list of all the variables. It's what information are we collecting on our who? What information is she collecting about those treadmills? It says top speed, brand, model number, inclinability, comfort rating, cost, and weight. So we want to list all those. So top speed, brand, model number, inclinability, comfort rating, cost, and weight. We'll squeeze it up here. So top speed of a treadmill is probably going to be measured in miles per hour. So like 10 miles per hour, for example. And remember our question, because we also want to label these categorical or quantitative. And the question we have to ask is, would the value for this variable or the values be numbers with units? If it would be numbers with units, it's quantitative. If not, it's categorical. So top speed, we just said an example, top speed could be 10 miles per hour. That's a number with units, so it is quantitative. Then weight would be like, is it 80 pounds, 250 pounds, and so on. Those would be numbers with units, so also quantitative. Brand, that would not be numbers with units, that would be like I think there's maybe like a brand called like Pro Plus or Nordic Track. So those are not numbers with units, that'd be categorical. Then model number, that would be like, say the model number is like, let's say it's a Nordic Track treadmill and the model number is 120054. So that's just like the model number the company uses to keep track of the different treadmills and so on. So our number is 120054. Now this one, be careful. It is a number, but there's no units. It's just the model number. It's not 120054 pounds or anything. It's just like a indicator, like a label for that treadmill. So this one, even though it's a number, it doesn't have units, so it's categorical. Then inclinability, can it kind of lift up so that it's like a hill or not? Does it only stay flat? That says it's a yes or no answer. So that is categorical, not numbers. Comfort rating, poor, good, excellent. Those are not numbers with units, so it's categorical. And then cost, that's going to be quantitative. X number of dollars or units, so quantitative. So let's zoom out a little bit. Then let's see, what are our other W's? Again, there's 6 in total, 6 W's. Who, what, when, where, why, and how. How is, we'll call it a W because it has a W on the end. So when, does it tell us when? It does, it says in fall of 2017. Where, it says Amarillo, Texas. How, this one I think is maybe tricky sometimes to figure out what word is best. Let's see, it says she tested the treadmills. She's not surveying anyone, she's not interviewing. She tested the treadmills. So maybe we can say something like testing or observation. She's observing them as she tries them out. And then why? It says she wanted to find the best treadmill brand and model. So to find best treadmill for her gym. So that's 6 W's. Let's go ahead and move on to our last practice. Doing the same thing, 6 W's. So let's go ahead and pause the video and give this a try. In Russia in 2003, Brendan was training for a big athletic event. He wanted to find out the most effective meal to eat after his training sessions, and so tested out 7 different possibilities. For each meal, he recorded the following cost, cost, calories, carbs, protein, fats, and whether he would want to eat it again. So let's go ahead. We'll start with who. So what is our who? Is it Brendan? No, be careful. Remember, who is the person or thing or things you're collecting data on? He's not collecting data on himself. He's collecting data on these different meals to eat after his training program. And he tries out 7. So who is the 7 meals he tests out? Now let's move on to what. So what are the different pieces of information he's collecting on these seven meals? In other words, what are our variables? Well, it says, let's see, cost, calories, all these. Cost, calories, carbs, protein, fat, and whether he wants to eat it again. So let's go through and do quantitative versus categorical. Cost, that'd be quantitative. Does it cost $10? That's a number with units. Calories. So let's say the meal has like 800 calories. Calories are actually a unit. So number, units. So calories would be quantitative. Carbs, it tells us it's measured in grams. Does it have 60 carbs and so on? So that's quantitative. Protein, it also tells us measured in grams, so quantitative. Does it have 30 grams of protein, 40 grams? And fat, same thing. It tells us it's in grams, number with units. But then would he eat it again? That's kind of like a yes, no question. So that would not be a number with units. That'd be categorical. Let's keep going, see if we can come up with any other ones. Where, when, why. So where, it says in Russia. When, it says in 2003. Why? To find out the most effective meal after his training sessions. To find most effective meal for after his training sessions. And then lastly, how. Again, this one's not, I don't know, it's not too clear what to put. It just says, let's see, we wanted to find out the most, so he tested out 7 different, so it's kind of like the last one. It says he tested him out, so that's kind of like testing or observation. He's not setting up an experiment really. He's not surveying people, quizzing people, interviewing people. So something like this, testing or observation. So this one, we were able to find all 6 W's, but again, keep in mind, sometimes the information won't be provided, so just leave it blank. So with that, let's go ahead and work on the classwork.